let's solve another questions. Before solving the questions, we know that CCT is clock cycle time. And there is one more formula where CCT is equals to 1 by R, where R is the clock rate. In the previous video, I told you that the formula of execution time is CPU clock cycle into CCT, where I have changed the CCT into the clock rate. It means CCT is equals to 1 by R. CCT is equals to 1 by R. Let's solve one questions by using the CCT equals to 1 by R. The question is two machines M1 and M2 having clock rate and the clock cycle per instruction has 50 MHz megahertz. It means the machine M1 has clock rate 50 megahertz and CPI is 2.8 as per the question given. And same for the machine 2, the clock rate is 75 megahertz and CPI is 3.2. The question is working on the same instruction set, which machine is faster and how much? The question is working on the same instruction set, which machine is faster and how much? Let's solve these questions. For machine 1, clock rate R1 is 50 megahertz and CPI is 2.8. Okay, so we have to change the megahertz into hertz, and we know that 50 into 10 to power 6 is hertz. Okay, then we know the formula execution time ET is equals to IC into CPI into CCT. Okay, here in this question also the IC is not given, so you can take the IC equals to 1 and CPI is 2.8 instead of CCT. In this question the clock rate is given. We know that CCT is equals to 1 by R. It means 1 by R. Okay, then 1 into 2.8 into 1 by R means 1 by 50 into 10 to power 6 hertz. By solving this, we can get 0.056 into 10 to the power 6. Let's solve for the machine B. Machine 2 or B. Same, in this question, R2 is equals to 75 megahertz. So we have to change the megahertz into hertz. 75 into 10 to the power 6 hertz. And CPI is given is 3.2. Same, using same formula, ET is equals to IC into CPI into CCT. In this question, instead of CCT, clock rate is given, so we have to change the formula IC into CPI into 1 by R. Just put the value, IC is not given, then 1, CPI is given 3.2 and 1 by R means 75 into 10 to the power 6 hertz. By solving this, you can get 0.043 10 to the power 6. By seeing the value, we can tell that the execution time of machine 2 is slower, it means the machine 2 is faster. But the question is not in here. The question asks is how much faster. It means if the machine 2 is faster, then how much? Let's solve for this. We know that performance is indirectly proportional to the execution time. It means P equals to 1 by E. So performance of machine 2 by performance of machine 1 is equals to time of machine 1 by time of machine 2. We know that machine 2 is faster, so PM2 is equals to PM1 by TM2 into PM1. Just put the value of time. TM1 means execution time of machine 1, 0.056 into 10 to the power 6 divided by 0.043 into 10 to the power 6 into PM1. By solving this, we can get 1.302 into PM1. Then it means 30.2%. Or we can say that the machine 2 is faster by machine 1 by 1.302. Thank you.